I'm thrilled to be here with you to discuss the opportunities from the data revolutions to support healthier and more sustainable oceans for our planet and for all. The oceans are our life support system on Earth. Oceans provide food for billions of people, regulate climate, support economies, and host a large fraction of the biodiversity of this planet, largely unexplored. At the same time, these important functions are at risk from rising temperatures, marine heat waves, ocean acidification, pollutions, and many other impacts. And one of the main obstacles to developing solutions to this crisis is that we barely scratch the surface of our knowledge of oceans, especially at depth and offshore. Studying oceans is hard. It's difficult, and there's many challenges. However, in the last decades, we've seen true revolutions in our ability to explore, to discover the oceans, and to track change. And this has been termed the data tsunami for oceans. In the last 20 years, we've learned more about oceans than in the previous century, thanks to advances in environmental sensors, biologging, and satellite tracking, as well as developing artificial intelligence and machine learning. An example of these revolutions come from satellite tracking, particularly the automated information system that mandates boats above 50 meters of length worldwide to carry transponders, trackers, that signal their identity and position every few minutes worldwide. This found data were collected for a different purpose, specifically safety at sea, have opened up a whole new world in our ability to track what's happening out in the ocean. Because vessels have different behaviors when they're at sea, machine learning advances allow us to use this data to discriminate different ocean uses. For example, seabed mining from fishing, and even different kinds of fishing. And for the first time, we have a global view of fishing at sea. For example, as you see in this map, where fishing is most intense, how it changes through time, how it responds to environmental conditions or global shocks like the global COVID pandemic, for example. This, in turn, has vastly increased our ability to manage these activities, to address major challenges such as illegal and unregulated fishing, and support a more sustainable use of the ocean. So there's great potential in these advances. Another example that I want to discuss comes from exploration of how blue foods, the fish, shellfish, and seaweeds that are grown or harvested from aquatic system might contribute to a more sustainable and a more equitable and healthier global food system. A group of over 100 international scientists came together in an initiative that is called the Blue Food Assessment, that address questions around blue foods that range from what might be the potential of blue foods to address malnutrition, nutrient deficiencies that affect nearly 3 billion people worldwide, to the potential of blue foods to provide resilience in the food system and the future climate change scenarios, to the environmental footprint, the different pathways for fisheries and aquaculture development might bring. One example of the contribution of data science in this area relates to an assessment of the nutritional benefits of blue foods. Scientists in the assessment assembled the first database of nutritional profiles of over 3,500 different species of seaweeds, fish, and algae from aquatic systems. And this enabled, in turn, to provide an analysis and synthesis of the content in terms of omega-3 fatty acids, iron, zinc, vitamins of these different foods. And so this analysis highlights, first of all, the huge variability that exists among different species, and also the most valuable species that includes, for example, some shellfish or small pelagic fishes that provide alone in a single serving meet the daily requirements of these important nutrients. So this database and analysis provides decision makers and the public with a really valuable tool for determining which production systems, for example, might be most effective in addressing malnutrition. So this effort, together with the other studies that were conducted as part of the assessment that address climate change, environmental footprints, the role of small-scale holders, were integrated in an online open access tool that enables decision makers to assess the potential of blue foods in meeting 4 policy objectives: reducing nutrient deficiencies, supporting human health, particularly reducing the risk of cardiovascular disease, reducing the environmental footprint of food production of the food system, and supporting food production and access under future climate change scenarios. And so this tool enables at a country level scale to examine potential win-wins, for example, supporting the production of foods that meet both the nutritional requirements as well as have a low environmental footprint and are resilient to future climate change. So there are some win-wins that, if leveraged, can provide really important solutions to the food crisis. So we are at a really critical and exciting time in how the data revolution can contribute to ocean health and sustainability. And there are essentially 3 pillars that have seen major developments but need more. The first is an ability to collect data in real time at scales. And so further advances in technologies, for example, are urgently needed. The second pillar is continue to leverage analytical capabilities and advances to extract important insights from these new data streams. And finally, platforms that make these insights accessible to the public and decision makers, and continue to develop advances in data access, transparency, visualization. So it's all hands on deck. There's a need, an opportunity for different fields, different stakeholders to come together to meet this important challenge. This is a time of partnership and collaboration towards a healthier and more sustainable planet. Thank you for listening.